And welcome, ladies and gentlemen, to Chapter 9, Lesson 3, Solving Rate Problems. Today is in the third lesson of the book, but we're going to be doing a worksheet assignment soon to come. I'll talk more about that. Go ahead and pause, take a look at your answers. Come on back when you're ready. You know I love questions. Bring your questions to class, please. And here we go with proportion. Well, I will solve problems with proportions. And remember, please, that when we do proportions, it's not always going to be a nice, easy scale factor is what we'll eventually call it. So when you do that, we're going to talk more about multiplying diagonally and making a new relationship where the product of the diagonal numbers, 7 times x and 5 times 32, are still equivalent, and therefore we can solve. So here we go with some examples. If you'd like, you're welcome to pause, read on your own, but otherwise I'll read it with you. Nicholas bought 5 pens for $3. How much will he spend on 12 pens? Now, the first thing you want to do is define the ratio terms, and naturally, dollars depends on pens. You can't figure out how much he owes until you first know how many pens. So we're going to set up dollars to pens. Then we're going to use the problem, and if you'll forgive me, I'm going to put a little disappearing ink here. I usually put the dollars to pens, so that you can see why the numbers go where they do. There's a relationship of $3 to 5 pens. There's a relationship of some missing amount, we'll call D, to 12 pens. Now we can use our cross products to write a relationship 5 times D is equal to 3 times 12. So there's no simplifying 5 times D. That's an unknown number, but 3 times 12 is 36. Meanwhile, we want to know what D is, and you already know what's coming. Now, I've considered giving you the use of a calculator on this assignment. Time will tell, time will tell. Don't forget your units, by the way. Tell me what that means. It doesn't mean buttons. It doesn't mean carpet tiles. $7.20. If you were to put that in, you'll notice 3, a little smaller than 5, a little more than half of it. 720, a little smaller than 12, a little more than half of it. So it makes sense. Onward we go to another one. Renee bought 3 tickets to a concert for $75. How much will it cost for 5 tickets to the concert? Again, first things first, we're comparing, is it tickets per dollar or dollars per ticket? And you know that the dollars will depend on the tickets. So I go ahead and set up ratios, dollars per ticket, and then we put the numbers in. $75 is 3 tickets, and we have an unknown number of dollars for 5 tickets. Once again, we're going to create a relationship of cross products. We're going to multiply diagonally. 3 times D is equal to 75 times 5, or 5 times 75 for that matter. Now, in simplifying this, there's no way to understand what 3 times D is. D is missing, but 5 75s is 37, 375. Naturally, we'll divide both sides by 3 because we want to know what a single D is. And in this case, you will not have to round. It does divide perfectly. How about 3 more examples? Here we go. Chantel runs 25 miles per day while training for a marathon. How many miles will she run in 4.5 days? Now, what depends on what? Oh, you know what? It already even says miles per day. Well, you could do the relationship the other way. Miles per day makes more sense. After all, you won't know how many miles until you first know how many days that she's running. So we set up the relationship miles per day, and then you see that 25 miles per day, singular, is 1. 4.5 days is what we have, so we are missing the number of miles. Let's go ahead and solve our equation. We're going to multiply the relationship. Hey, guess what? 1 times m is 1m. Meanwhile, 25 times 4.5. As mentioned, I most likely will allow you to use calculators. So we get 112 and 5/10. Now, folks, little disappearing ink here. Yes, I suppose you could divide by 1, but guess what? You've already solved the equation. We wanted to know what a single m missing number is, and so we have found the answer to be 112.5 miles. Onward, here we go. School cook uses 10 pounds of potatoes to make mashed potatoes for 40 students. How many pounds of potatoes does the school cook need to make mashed potatoes for 120 students? Now, pounds per student or students per pound? Pounds per student or student? I suppose that the pounds of mashed potatoes will depend on how many students are eating. So again, real quick, I'm going to write pounds per students, pounds per students. The question is asking 120 students, and we don't know how many pounds. Sometimes I'll use P, sometimes I'll use X. Meanwhile, naturally, 10 pounds, 40 students. So we can now, with this relationship in mind, set up an equation and multiply. We have 40 times some unknown number P is equal to 10 times 120. Now, naturally, we can simplify, not the left side, of course, but why write 10 sets of 120 when you could write 1,200? Then we'll go ahead and solve. I don't want to know what 40 p's are. I want to know what a single p is. And don't forget, you can reduce by 10 to make your life easier. In this case, it will be 40 pounds of mashed potatoes. Excuse me, I said 40. I wrote 30. 30 pounds of mashed potatoes. And I think I got one more. Let's try it. Bob worked 3 hours, made 18 bucks. If he works 5 hours, how much money would they make? Would he make? Go ahead and pause. Come on back when you're ready. Do this on your own. Dollars per hour. Again, you could do hours per dollar. It'd be interesting to look at that. But I'm going to go ahead and set up a relationship of dollars per hour. And we have $18 made in 3 hours. We have some missing amount of money made in 5 hours. And so here we go. Multiply diagonally and find the cross product of 3 times D and 18 times 5. Now 3 times D cannot be simplified, but 18 times 5 can be. But Mr. Callan, we want to know what D is. You're right. So let's split this up into 3 groups, and we would get $30 earned. And again, don't forget, use your number sense. Pop that in. And I should keep pointing out, could 3 have gone into 5? No, not nicely, that is. So it's really hard to do that scale factor. Whoops. And then you can go back. This one, silly Mr. Callan, 40 times 30 is 120, 40 times 3, so 10 times 3. I shouldn't have even done the cross products. Backward, 1 times 4.5, 25 times 4.5. No need to do the cross products. But it's not always that simple, right? Again, 3 does not go into 5 evenly, so the cross products is the best way. And 5 does not go into 12 evenly, so the cross products would be the best way. So what I'm going to ask you to do is complete the assignment. You need to do all your work on paper. Let me say that again. You need to all your work on paper. The worksheet, I call it 9B2B because it's from the second lesson. Actually, it's the third lesson, more like. Should have called it 3B. Anyways, go ahead and write and solve proportions for word problems. Bring some questions. Love to have them. Let's grow. See you, folks.